Today's video lesson explores the graph and check method of solving a system of linear equations. On this screen we've got the three types of systems. The kind where we have intersecting lines, which would be the one solution type. That one solution is the point of intersection of those two lines. We have the no solution type, where the lines never cross, so there's never a point in common to both lines. And there's the infinitely many solutions, which are actually two lines overlapping right there. Graph and check and all of the other methods to find where the solution is all refer to the one solution type. And the task that these methods do is help us to find where is that point. And so the solution to that should be some kind of XY pair as the solution for the system of linear equations. So here is a system of linear equations. I have two equations. Neither of them are in slope-intercept form, and so my first task before I can graph them is to put them in slope-intercept form. For convenience sake, I will call the top one equation 1 and the bottom one equation 2. In equation 1, it's almost in slope-intercept form. I've just got that 2 as a coefficient of the y. So if I rewrite the equation and then do some solving steps to get y by itself, which would then put it in slope-intercept form, that would mean I should divide every term by 2 to simplify this to 1y. Well, this simplifies to 3x plus 4. Now it's in slope-intercept form and I can graph it, which I'll do in a minute after I get equation 2 in slope-intercept form as well. Well, this time in equation 2, the y variable does not have a coefficient in front of it. I guess it does technically as 1, but it's got this 4x on the same side. So we'll subtract 4x from both sides, and I'm going to squeeze that in here because the x term goes before the constant. This is gone. Y is equal to negative 4x minus 3. And so now this one is in slope-intercept form. Now let's graph them. Y equals 3x plus 4 has a y-intercept of 4, and it's got a slope of 3, which means it's going to go up 3 units and right 1 unit. If I write this or express that with rise and run, I've got a rise of 3 and a run of 1. So that means it's going to go up 3 units from there and right 1 unit from there, which looks like it also goes through that point. I could follow this conversely and say it goes down 3 units and left 1 unit. Just to help me graph it, I'm going to keep plotting points using that rise and run. So that line should look something like that. I may not draw this very accurately, but you try to do the best you can because this method we're trying to figure out where the lines cross and we need to be as precise as possible. Going to equation 2 now, this one crosses the y-axis at negative 3, which is its y-intercept, and it has a slope of negative 4, which is also a rise of negative 4 and a run of 1. Well, if I go down 4 units from where it crosses the y-axis, I'm now off the graph. So let's go in reverse order and say actually up and left instead of down and right. From the y-intercept, if I go up 4 units and left 1 unit, it looks like it crosses right there at this point that I plotted already on the other line. I'm guessing then that that is the solution to the system because they're both going to pass through that point, which means I have estimated that negative 1 is the point of intersection of these two lines. Now I need to check that and make sure that that's really where the solution is using algebra and substitution. So I just figured out that my solution is negative 1, and I need to make sure that this works in both equations. So let's first check it with equation 1 by substituting those values. This one's kind of easy since both the x and y are negative 1, but you should be careful and pay attention to what you're substituting in place of x and y to make sure you're putting them in the right spots. So 2 times negative 1 should be equal to, and I'm going to put a question mark because I'm checking, 6 times negative 1 plus 8. So I get negative 2 could be equal to negative 6 plus 8, and sure enough, I just caught my mistake. It's not -1, -1 as the solution. it's -1, +1. So that's going to make a difference. So I should have inserted a +1 in place of y, which would have made this +2 there. And -6 plus 8 really is +2. So now my solution checks out since I caught my mistake. And that's how you check your solution after you've graphed it. Here's another example. Let's see if we can work through this one a little more quickly. Fortunately, equation 1 is already in slope-intercept form, so let's go to the graph then. The y-intercept is 4. It has a slope of 4, which is a rise of 4, run of 1. I'm going to go backwards. Again, that would put me off the graph, so I'm going to go down 4 and left 1, and that's going to end up right there. I'll do this a few more times just to help me graph this. Looks like those are the only points where I can sort of estimate. So my line's going to look something like that. Equation 2 is not in slope-intercept form, so let's write this out so that we can set it up in slope-intercept form. Divide every term by 2. Reduce y is equal to -3/2 x minus 7. Now it's in slope-intercept form. It's going to pass through the y-axis at 7. It has a slope of -3/2, which means the rise is -3, the run is 2. So I could go down 3 units and right 2 units, but that's again off the graph. So instead I'll go up 3 and left 2. And if I go up 3 and left 2 again, it's going to be there. And my graph looks something like that. Now this very clearly illustrates that it's hard to tell what that exact value is where those two lines intersect. Well, I just made another mistake actually. Let me back up just a little bit. My y-intercept was good. I should have gone up 3 and left 2 units, which ends up right there. So that is actually the point of intersection, which is at -2, -4. And now I need to check this solution. With a solution of -2, -4, I need to go and plug this into both equations and see that it makes true statements. Equation 1. 4 times -2 plus 4. So I get -4 equals -8 plus 4. -4 equals -4. So it works for equation 1. Let's check equation 2. 2 times -4 should be equal to -3 times -2 minus 14. So this is -8. That makes a +6. And that one also works. So I've checked my solution and I have found the correct one. Please note, if I had continued with the mistake that I had made earlier, I would have come up with some fraction answer. When I had inserted that into these equations, I would have seen, hey, that doesn't work out to equals like it did this time, and then I would have known I estimated my solution incorrectly. Here are the two problems that I'd like for you to work out. You may need to draw your own graphs, or you can print this page to be able to print it on the graphs that are supplied. Please remember that you need to rewrite these equations in slope-intercept form so they say y equals and everything else is on the right side. Good luck, students.